Alright guys, let's do 9-4 rational expressions. Excuse me. We're going to start with the first objective, which is simplifying rational expressions. Before we really jump into that though, we need to revisit something that we had seen earlier in the year, and that's stating the restrictions on the variable. So you really might consider doing that right out of the gate because it's going to make it easier for you. You have to consider your restrictions from the very beginning, and then also again you want to reinvestigate, reevaluate those when you're done, because today's are pretty much easy, but the ones when we're doing the multiplying and dividing, that's when you could possibly have something flip from the numerator down to the denominator. Alright, so let's go ahead and take a look at our first example. We have simplify x squared minus 6x minus 16 all over x squared plus 5x plus 6. And it says state any restrictions on the variable. Well, obviously, this is given to us in terms of trinomials, and we can't simplify because remember, if we just mark out that x squared, we're going to kill a kitten somewhere, and that's sad. Nobody wants to do that. So take your C value, and in this case it's negative 16, and are there characteristics, or are there factors of negative 16 that would give you a negative 6? And in this case it would be negative 8 and 2. Ooh, this is off. Okay, and then the 6, we could either have 1 and 6, or we can have 2 and 3. Be careful to not do 1 and 6 because this is plus, so that means they have to have the same sign. So you're going to go with 2 and 3 on this one. So in the numerator, we have x minus 8 times x plus 2. And in the denominator, we're going to have x plus 2 and x plus 3. All right, now we want to state the restrictions now because it's there, and you have to take into consideration even any factor that might cancel out, because it still would cause your original function to be undefined at that particular value for x. So you're going to do x plus 2 equals 0 and x plus 3 equals 0. Basically, these are points of discontinuity. You're not stating whether they're vertical asymptotes, holes, or anything. You're just saying that at this particular location in the graph does not exist. The function does not exist. Okay, so there's a restriction at x is negative 2 and x is negative 3. Now we go up here, cancel out any like factors, and in this case, x plus 2 and x plus 2. One's in the numerator, one's in the denominator, right? And so that leaves us with x minus 8 all over x plus 3. Now for some crazy reason, I have kids who want to cancel out those x's. You can't. That is part of the expression. That's saying some value of x minus 8. This is saying some value for x plus 3. If that were 2, it'd be 2 minus 8, 2 plus 3. So you can't just cancel out those x's just because you have one in the numerator, one in the denominator. This is part of a difference, and this is part of a sum. Okay? So the answer would be this, because that's your simplified, but then you also have your restrictions. X cannot equal negative 2 and x cannot equal negative 3. Okay, now the word problem. And this one is not bad, but what's intimidating about this is that you're using formulas that we had learned in geometry that we haven't really seen a lot of this particular year. So that's what's tough about this one. Otherwise, it's pretty simple. It tells us one factor in designing a structure is the need to maximize the volume. These are maximization, optimization type problems for a given surface area. Compare the ratio of the volume to surface area of a cylinder with a radius r and height r to a cylinder with radius r and height 2r. Okay, so it's volume to surface area, and that's right there, volume to surface area. So volume is in the numerator, surface area is in the denominator. Same basic general formula, but in the second step here, they substitute in r for the height and then the 2r for the height. So then they go through and simplify both. R fourth equals R third. So the ratio of volume to surface area is greater for the cylinder with a height of 2r, which quite honestly most of you probably would have already expected that. Okay, so, and that's because r thirds is greater than r fourth. This is 0.25r, this is 0.3r. Okay, all right, so now compare the ratio of the volume to surface area of a sphere with radius r with the ratio of volume to surface area of a sphere with radius 2r. And they are giving us the formulas, right? So we know one has radius r, one has radius 2r, and again, it's telling us volume to surface area right here. So volume to surface area. So we're going to have 4/3 pi r cubed all over 4 pi r squared. Now, you could go about this two different ways. You could simplify this and then plug in your variable, or you could just go ahead and plug in the value for r and the value 2r and go from there. Completely up to you. I'm going to go ahead and do this. Our radius is r, and then over here this is going to be a sphere with radius equal to 2r. Okay, so I'm just going to go ahead and leave it as is, although I'm going to have to erase this part because, and I guess I could have just left that and then just plugged in the next one, but I want to be as efficient as possible here. All right, so I've substituted in the value for r, which is 2r in this case, in wherever I had an r. So that's the expression 2r cubed and the expression 2r squared. So let's go ahead and simplify this one. The pi's are going to cancel out. R cubed over r squared is going to leave you with just an r in the numerator. And then you have 4/3 divided by 4. So 4/3 divided by 4 is the same as 4/3 times 1/4, which is going to be 4 over 12, which is 1/3. And then I still have this r. So we have 1/3 r, or r over 3. That was kind of sloppy. Sorry about that. Okay, over here. These are going to cancel out. And we know, again, just from over here, 4/3 divided by 4 is going to end up giving us 1/3, right? So you have 1/3 times 2r cubed over 2r squared. Well, 3 minus 2 leaves you with 1. So then you have 1/3 times 2r, which is going to be 2r thirds. So we have r over 3 and 2r over 3. So obviously the volume to surface area of a sphere with radius 2r is greater than the sphere with a radius of just r. Okay. All right, that is it. Hopefully that's okay. So again, not hard. Hopefully this one is actually kind of old. But it's using those different formulas. So, all right, please let me know if you have any questions.